So, with the name of Allah, today we'll be learning about the spreadsheet formation of consolidation test calculation, how we basically form the spreadsheet of consolidation test. So, some of the things I have already incorporated in the sheet, which I think are not necessary to incorporate while making the video. So, that is why I have already incorporated these things. The second thing is, please, it's a request, try to watch the video online, and the handouts regarding the consolidation test are provided in the description box. Also, you can join our Facebook page with the same name as my channel, YouTube channel is. So let's start the process or Excel sheet formation. So here is the input data. You will have to find out the initial height of the soil sample, that is 2 centimeter. In my case, the rings height is basically 2 centimeter and the half sample is 6 centimeter. It will vary as per your apparatus, so you will have to deal it with carefully. Next, you will have to find out the cross-sectional area. Because it's a circular ring, so I'll have to apply the formula pi r square. So, or pi d squared by 4. So, I'll be applying the formula here, pi, which is equals to 3.14156 multiplied by dia, that is basically this value. Then it is again multiplied by this pi d squared, bracket close, divided by 4. And this is how we have found out the cross-sectional area. Now it's the least count. In my case, the least count of the dial reading, displacement dial reading, is 0.001 centimeter. So if I multiply the reading of dial gauge with 0.001, then the value will be centimeter. So it depends upon the calibration of the equipment. In my case, it's 0.001. You will have to deal as per your condition. Next thing is specific gravity, 2.65. If you measure the specific gravity, then you will have to use that value. Otherwise, you can use 2.65 value, that is standard. Now, the density of water is 1 gram per centimeter cube. Drainage condition is doubly drained condition I'm using. If you are using singly drained condition, then in the determination of coefficient of vertical consolidation, HDR will be different. So, method used for curves, I'll be using Taylor method for determining the coefficient of vertical consolidation. Then you have to determine the weight of the ring, that is 42.25 gram. In my case, it will vary as per your apparatus. So then, firstly, you prepare the sample. Either it is undisturbed or disturbed sample. The detail of disturbed and undisturbed sample is given in my previous lecture of consolidation test. Each and everything is explained there. Here we'll only concern about, or we'll discuss about the calculations only. So weight of the wet soil plus ring before test. In my case, the case study I have taken is 157.76 gram. So these are actual values I have taken from one of the experiments performed. So these are the input values you must have. Then another two inputs you must have. Weight of dry soil after test. Then you will have to determine weight of the soil that is dry after the test. This is obtained by oven drying. So it's in my case 138.9. See, weight of dry soil, only soil solids will be same before the test and after the test. Only thing will change is the weight of water before and after the test. So that is why here the wet weight of the soil plus ring after the test is different. So what is the difference between the initial moisture content and final moisture content will be elaborated in few seconds. So here we'll have to find out in the first step initial moisture content. So firstly, as we know that moisture content is weight of water divided by weight of soil solid. So weight of water, if I subtract wet soil plus ring minus weight of dry soil plus ring, sorry, it is weight of dry soil plus ring, I'll correct it as well. So I'll select this one, subtract this one, and it will be 18.8. I'll make the fraction over here plus ring weight. So now it is in gram. So the next step is to find out the weight of soil solids. If I subtract this minus weight of the ring, then I'll obtain weight of soil solids. Now moisture content, I earlier told you that it is weight of water divided by weight of soil solids into 100. So this is how we'll obtain the moisture content, that is in percentage. It is initial moisture content. So it is in percentage, you can express here. Now the second step is to find out the final moisture content. See, wet weight of soil plus ring after the test, that will be changed after the test and before the test, because during the test there is removal of water, so there may be change of weight of water after the test. So because soil solids will not be changed, the weight of soil solids will not be changed, it will be constant, because particles of soil are not moving out of the ring or sample. So that is why the weight of dry soil before and after test will be remain same. Only thing will change is the weight of the wet water. So I will have to find out the weight of water after the test. So if I subtract this minus dry weight of the soil plus ring, and here I will obtain the wet weight of the water, 18.1 gram. Now weight of the soil solids after the test, as I told you, it will be the same. So I will not apply the formula, will directly choose this value here. Now we'll find out the moisture content, that is this divided by this, bracket close, into 100. Yes, so this is the final moisture content. It is in percentage, here it is in gram value, it is in gram value. So third and the most important step is to find out the initial void ratio. Initial void ratio formula is H naught minus HS over HS. H is basically height of soil solids, which is obtained from this formula. The explanation of this formula is given in the previous lecture. So I'll just apply this formula here. So what is MW here? MW is mass of wet soil, excluding the weight of the ring. So that is why after the test, so I will select this value and will subtract the weight of the ring. This is weight of ring, you can see here. So weight of ring I'll have to subtract. Now MW is clear, divided by, so I will have to select the cross-sectional area, this one, then multiply GS specific gravity, then multiply with the density of water 1, then multiply 1 plus moisture content, this is MC's moisture content after the test, or final moisture content, I will be selecting this one, divided by 100, and the bracket is closed, and we'll select yes. Okay, so here is the value of HS, that is in centimeter, 1.29 centimeter is the height of soil solids. So now E naught is equals to H naught, that is 2 centimeter, minus HS, this value, divided by this value. Okay, so this is the initial void ratio. So step 3 is finished. Now we'll have to find out the step 4, that is E versus log peak curve. We draw the E versus log peak curve and we find out C sub C, that is coefficient of compressibility, or you can say coefficient of or compression index or swelling index, and then recompression index basically. Sorry, it is compression index. So here we have pressure in column A. So I will select by applying this formula. Pressure is 25 kPa, then 50 kPa. Why I'm selecting in that manner? Why I'm not directly putting the values? Because in the future you will just have to put these values, and these values will automatically be reflected over here. That is why I'm using this formula. Then 100, then 200, then 400, then equals to again unloading, then 100, then 50, then again reloading. This is 100, and then 200, then 400, then 800, and then 1600. So what is the benefit of selecting in this way? These values, if you will change any value over here, it will automatically be changed over here. So next thing is initial dial rating at the start of the test. We are taking it as 0. You can adopt the second approach, will be discussed later. So it is 0 at the start, and the final dial rating of the heavy loading. So 25 kPa, and look, what is this? These are observation and readings. Here it is the loading values, 25 kPa, 50 kPa, time intervals, and these are dial readings. You will have to record these values during the practical. So it comes in the pocket of your input values. So next is to have the final reading of the displacement or dial reading caused by this 25 kPa loading. So I will again apply the formula over here. We'll click the sign equal, and we'll select the lost values. So whenever you will change these values, it will automatically be changed in this 61. Then you will have to select this one equals to 157, then 153, then 148, then equals to 140, then equals to 143. These are the readings. 149. Okay, so okay. After 143, it is this value basically. So 149. After that, this one, and this one, and the last value 309. Okay, now the next step is to convert these values into the centimeter. So delta H, we have to find out the change in thickness. So if we multiply 11 with the least count, that is 0.001, the reading will be in centimeters. That will be subtracted with the initial reading and will obtain the delta H, change in thickness. So we'll apply this formula. We'll click this one and we'll multiply least count here, this value, but here you will have to apply the sign dollar because I have to use this constant value throughout the column. So that is why I am fixing this value. I will close the bracket here and here. This step you will have to do very carefully. So this, and then you will have to subtract from this value. So now the delta H has been found out. Now if you will drag this, the same formula will be correctly applied to each and everything. If you didn't choose dollar sign, then you may not find the correct formula here. So I hope you understand why I use formula. Yes, because 0.001 is the value will be constant throughout, only these values will be changed. So if you are choosing the constant value that will be applied throughout the column, so you will have to apply the dollar sign. Now the next step is to find out delta E, that is delta H over HS. So I have found out the delta H divided by HS, that is this one. Again, this value is constant that will be applied throughout. So that is why I will use here the sign of dollar, shift 4, and this is applied. Now I will drag this one and I will obtain the delta E values. Now I will have to obtain white ratio, that is E naught minus delta E. So I will apply the formula. E naught I have found out this one. Again, this is constant value that will remain constant for the column. I will apply the sign of dollar here minus this value, and okay, now I will check this one. So I have obtained both things, E here and P here as well. No, you see these will automatically be changed if you change anything over here. So now the next step is to draw the graph E versus log P. So I will go to the insert. Here I will select this column. Okay, now right click, go to select data, add along the x-axis. So now what we will do is we'll select the along the x-axis there will be pressure values. I will select these values, and along the y-axis there will be white ratio, this, and okay, yes, now the graph is plotted. The next step is to convert these values into log scale. So I will select this, double click, and here I will select the logarithmic scale, and now the graph is okay. Now E versus log P graph is plotted. E versus log P graph. So it's plotted. E versus log P. Now the next step is to find out CC value. Now I will have to select E1, so E1, E2, here P1, P2, and here I'll have C sub C value. No, it will have to be done, you can say manually. So let's say I select this value 100 kPa load, and against the 100 kPa load I will be selecting this Y ratio. So this is basically against the 100, you can see this value, yes, and the next step I will be selecting E2 this value. So basically the slope of this line I will have to find out. So I will be selecting against the 200 compression part, okay, and this value is basically 200. Yes, now I will have to find out C sub C is equals to E1, this value, minus this value, so divided by log so now we'll have to divide by log P2 divided by P1. So for this one, we'll go to formula, here log formula. I'll have to select from here log. Here, this dialog box will open. Now you will have to select P2 this value divided by this value, and the formula is applied over here, CC. So my C sub C value is 0.139. How can I verify this value is accurate or not? For this, I have taken a reference of ranges. If you see this value, I have taken from one of the book. I'll mention the reference of these values in the description box. So here you can see CC value should be in the range of 0.1 to 0.8. So my value is correct. Now I will find out the I will have to convert this into formula like 100. I will collect this 100 compression marks. So, okay, now I will be finding out C as swelling index. So for swelling index, same formula is applied: E1 and E2, P1, P2, and here comes the C sub S. So what is the difference between these two actually? So the difference between these two is that these values will have to be selected from the swelling part, and C sub C value has been selected from this part, that is compression part, initial compression. So from this part we have to select two values. So again, what I'll do is, here is a trick. You will have to select the point E1 just behind the point you selected for here. Like if you have selected E1 here, then you will have to select the E1 for C sub S right below this, like here 0.435. So 0.435, 0.435. If I apply the formula for unloading, here you can see the unloading, this one. I will select this value 100, and then for 200, then for this value I will be selecting 200 here. Now I will be selecting this value. This is basically, so this is some mistake over here. Here I will be selecting the value corresponding to the 200, that is unloading this value basically. Now I'll have to select P2, that is 200 of unloading value because it is swelling in there. Here I will be selecting 100 of unloading this value. Now again the formula will be applied like this, E1 minus E2 bracket close divided by log this one. I will select 200 divided by 100. Okay, now it is 0.012. Now again I'll check the range value. This is the range. You can see 0.015 to 0.35 basically. So it's in the range. So my value is correct. Here you can see the CS and CR recompression slope is almost equal. So CR will be equal to CS recompression. So this is how we have find out C sub C and CR. In the next step, I'll have to find out the pre-consolidation pressure. For pre-consolidation pressure, I will be taking only loading value, not the unloading values. So it will be like 25. I can select this one, 25, 50, only loading part, 100, 200, 400, and the next will be selected as 800. I will jump to 800. This is very important to understand because we'll take only loading part. So now I have selected this one. Now I'll have to select the wide ratio corresponding to this one. So E value against 25 is this one. For 50 kPa is this one. For 100 is this one. For 200 is this one. For 400 is this one. For 800 is this one. And for 1600 is this one. Now I will plot a graph over here. We'll go to the insert. Then we'll select this graph. And then I will right click, select data, add along the x-axis. Again, there is pressure values. Select these values. For y-axis, I will have to select E values. So this is how I will draw a graph. No graph is plotted, but again, it will be in log scale. So I will select, double click over here, and I will convert this into log scale. So this is how you have obtained the log scale graph E versus log B. Now we'll have to find out the pre-consolidation pressure. This will be done manually. So firstly, I will select the point of maximum curvature. Like if I go over here, insert the shapes. So we'll draw let's say it is the point of maximum curvature. Draw a straight line here like this. This is the straight line from this point. Then draw a tangent at this point. Draw a tangent at this point, like here it is done. So I will just do what? I will draw a tangent over here. We'll draw a tangent like this over here. Now the next step is to draw angle bisector of these two lines. So let's say it will be done manually. It will be done manually. So I will draw angle bisector of this line. Let's say this is the angle bisector like this. So exactly like this. So let's say this is the angle bisector of this line and this line. Like firstly, draw horizontal line. Select the point, draw horizontal line, then draw a tangent that is AB, then draw angle bisector AF of AB and AC, then extend the linear portion of this curve backward. So what I will do is draw the linear portion of this curve backward like this. So where it touches the angle bisector line, where it touches the angle bisector line, where it touches the angle bisector line like this, corresponding to that value along the x-axis is basically pre-consolidation pressure. So our pre-consolidation pressure is almost 210 kPa. So here you can see almost 210 kPa. So 210 kPa is the pre-consolidation pressure. Consolidation pressure, you can say here. So this is how we can find out the consolidation pressure. Now the next step is to find out the A sub V and M sub V. A sub V, coefficient of compressibility. So how we basically find this graph? Let me raise this one to have sufficient space to work it on. So again, the same thing will be copied. I will copy this. The same thing, Control C and Control V. Same thing will be copied over here. Like I have to select these values. These are not done correctly. So what I will do is to select these values. Control C, Control V. Why it's not working? Okay, we'll do what? This value, this value, this value, this value, this value, this value, and this value. So now we'll select the wide ratio corresponding to these values. Now we'll draw a graph. We'll go to the insert and we'll draw a graph like this. Okay, the graph is plotted over here. Now the difference between A sub V and C sub C is basically that it is without log scale. So it will be without log scale. You will select two values, E1, E2 and P2 and P1 similarly like you selected here, but without log value. You will put the values over here and you will get the A sub B value. So like if I select E1, E2 and then P1 or P2 here, subtract this here or here, select P1, P2. Let's say if I select these values here, I will be selecting again the values against 100 and 200 kPa. So I will be selecting this value from here. You can select from the graph. The better practice is to use the graph. So we'll be selecting the corresponding values 0.502, this one, and I will be selecting this one. Now I will be applying formula A sub V, coefficient of volume compressibility is equals to E1 minus E2 but close divided by P2 minus P1, and this is how we obtain the A sub V. So similarly, if you put the values in this formula and you will obtain the N sub V. So N sub V is equals to A sub V, this one, divided by 1 plus E naught. We have here the value of E naught. So yes, the bracket will be closed and we have N sub V here. So this is the N sub V value. I'm not considering the unit. So the last step is to find out the coefficient of consolidation using the Taylor method. So for that purpose, I will have to select the time value. So here I'll be selecting this time value, this 0, again 1, 2, 4, 8, 15, 30, 60, 120, 14, 40, and now we'll have to select the square root of the time method as it is a square root of the time method. So I will go to the formula here, formulas, square root of the time method here. You can find out this here, this one, and you will have to select this value and OK. Now I will drag this one, obtain this. So these are the square root time values of this one. So now I will have to select the dial readings. So dial reading from here, this one. Look, I'll not be applying $sign, and because this is not fixed, that is why I'll select this one. Now the dial readings are there. Now I'll have to plot a graph, a very important graph here. So we'll select this one, select data, and add along the x-axis there will be square root of time values. So I will select these values. Okay, and then here is the values of the dial reading. So here is a concept. The graph is plotting, but there is a little bit conceptual thing over here. Firstly, dial reading should be increasing from upward to downward. Like here is 0, 1, 2, 3. It should increase in downward manner. Here is, you can see the downwards arrow. Then I will have to select how we can do this. I will select this axis, double click, and here I will select the values in the reverse mode. So here we have obtained the values in the reverse mode. So the next step is to find out how we can find out the C sub V value. So for finding out the C sub value, capital T90 is constant value according to the Taylor method 848. You can see in the formula here 0.84. Now we have to find out small T90. It is time for 90% consolidation. How I will find out this will have to be found out manually. How? Firstly, these are the steps. Firstly, you will have to extend the linear portion of the curve backward at the start of the curve. So what I will do there, we will insert the shape here. So let's say here it is the initial portion of the curve which is straight. So I will extend it here and will join this one to the y-axis. So next step, let's say it is 5.3. It is 5.3. Now I have to select another point C, which is 1.15 times of this B value. I have B value 5.3, will multiply 5.3 with 1.15. So it is 5.3 multiplied by 1.15, and it comes out to be 6.09. So I'll have to select that point here. So let's say here is the 6.09. So let's say here is that point. I'll have to draw a line from this point which will meet this point, where the initial curve is joining the y-axis. So where it touches the curve, this line where it touches the curve, corresponding to this we have T90, square root of T90 value. So like it is 4.9 approximately here. You can see the corresponding to this value we have square root of T90. So here basically this is square root of T90. I will write this value square root of T90 okay, let me show this value over here. Square root of T90 basically here, that is 4.9. So if I select this 4.9, now here I have to T90. So what I will do is apply a formula. Square of this value will be T90. So here is the T90. Now HDR. HDR is basically, sometimes in some books it is written as H0 minus D50 divided by 2. But you can see after the application of 25 kPa loading, there is change in height of the sample. So that is basically H0 minus this after the 25 kPa loading. So it is doubly drained, so we'll divide by 2 here for HDR. If it is singly drained, we'll not divide it by 2. So again, we'll select H0. H0 is there. We'll subtract, apply minus. How much change in thickness is occurred due to the application of 25 kPa loading? Sorry, this is not. Actually, this is the value. Now I will divide it by 2. Why I dividing it by 2? Because of doubly drain. So we'll take the average value of drainage path. So this has been explained very carefully. This is inside. So now we have to find the C sub V. C sub V stands for coefficient of vertical consolidation. Here the V stands for vertical. So because this is odometer test. So in this test, we are measuring the settlement in the vertical direction only. So this is C sub V. The formula is here. 0.848 basically constant value for the Taylor method, that is T90. So I'll apply the formula now here. Is equals to let me do this one first. Okay, is equals to 0.848 multiply by HDR square basically. So I will be putting square here divided by T90. This is T90 and equals to. So we have obtained C sub V 0.0349 centimeter square per minute. So this is how we obtain C sub V. Now what you have to do, you will have to find out the C sub V for 50 kPa, for 100 kPa, 200 kPa, and so on. I'll not be repeating this procedure for 50, 100 and so on, but you can do this procedure for yourself. Now the calculation is almost complete. You will make a summary at the end. Here you will make the formula sheet, like all the values are known. Now you have to find out C sub V for all the loadings. Then you take the average of these values. C sub V for 25, C sub V for 50 kPa and 100 kPa, you take the average value. Then we have C sub C, we have C sub S, C sub R, E naught, pre-consolidation pressure. I hope you know the basic definition of pre-consolidation pressure. And then we have a coefficient of volume compressibility, coefficient of compressibility. So these all things we have to determine using the consolidation of odometer test. So I hope you like the video. If you like the video, please do subscribe the channel for more videos.